Now that we've had an introduction to slope, I want to talk about parallel and perpendicular lines. So I'm going to start with parallel lines. And basically, parallel lines are lines with the same slope. Now, one thing to note is that they are different lines, so they do also have different y-intercepts, for instance, or different points along them, but they have the same slope. So what happens is they sort of look like this, for example. If one goes like this, the other one would go like this. So that they never touch, and they never also, of course, intersect then. So as an example, for instance, you could have one line is maybe 3x plus 5, and another line is 3x minus 1. So in both cases, sorry about that, guys. In both cases, you see a slope of 3, which we have right here. Now remember, when you're in that y equals form, we can find the slope as the value with the x. So if you're finding slope for an equation, don't forget you have to be in the y equals form or solve for y before you can find the slope. So here, these lines would be parallel. They have the same slope, but they are different lines, right? This one is a plus 5 intercept. This one's a minus 1. So they are different and distinct. Other lines that are also parallel, vertical lines are parallel to each other as well. And of course, so are horizontal lines, but the reason I mentioned vertical is because technically they don't really have a slope, right? Their slopes are undefined, but they still qualify as parallel. Perpendicular lines are the opposite of this. So they are lines whose slopes are what we call negative reciprocals of one another. Now, this is easiest, I think, to see with an example for a second. So if one slope, for instance, is positive 2/3, then the second slope would be negative 3/2. So the negative idea comes into the fact that you have different signs. And the reciprocal idea, remember, is that you would have a flipped version. So to take a reciprocal literally means to flip that fraction. So you have both of these changes are happening. So I like to think of them as perfect opposites. Oops, let's try that again. Perfect opposites. Couple other things that happen here. One, they do intersect, and they intersect perfectly at 90 degrees. Which is also a right angle. So it's an intersection we really like. Of course, the other thing that happens too is that the slopes multiply to -1. So for instance, if I use my example here, 2/3 times -3/2. If I multiply straight across, I get -6/6, which is -1. So that's another way that you can check that you have perpendicular lines. So as another example here, let's say one line is 5x plus 6, and the other line is -1/5 x minus 7, for instance. Now, in the first case, our slope is 5. In the second case, our slope is -1/5. Now, they do work here, right? One is positive, one is negative. And you do have a flipping action because 5 is the same thing as 5/1, right? So I can actually flip that to 1/5. So this is perpendicular. Now, if these two things don't happen, then we say that it's neither. So it's not parallel and it's not perpendicular. So what happens there is they do intersect. But just not at 90 degrees. So they do some sort of crossing, but at a different angle. So there's nothing wrong with it. It's just not particularly parallel or perpendicular. So as an example, y could be 3x plus 4 and y could be 2x plus 1, right? Here, your slopes are just totally different. M equals 3, M equals 2. You could also have something like this. So y equals 3x plus 4 and y equals negative 3x. So this one kind of always trips up students because they see that negative sign change, but because there's no flipping, it's not perpendicular. You need both of those things to happen for something to be perpendicular. So this is actually a neither. And the same thing is true if instead I had a 1/3 here. So again, you may notice that, hey, but this is a flipping action, right? Shouldn't this be something special? And it's not unless you have both sign change and flipping. So these are ones to watch out for. They tend to be a little bit trickier for students, whereas this is more obvious. So just be careful here. These are all examples of pairs of linear equations that are neither. And we do typically talk about these as pairs. So you could do, at least for parallel, more than two, but for most cases, we tend to talk about lines for parallel, perpendicular, and neither in terms of pairs here. All right, so let's just do one example. Determine whether I'm just going to do one pair, but each pair of lines is parallel, perpendicular, or neither. All right, and I'm going to look at the following example. So let's do this one. So I have 3x plus y equals 5 and 2x plus 3y equals 6. Now, notice right away that these are not solved for y. So before I even start comparing anything, I need to solve for y. I need to be able to find my slope, right? And it needs to be in that y equals form. Alternatively, you could find points for each of these lines and then use a different formula and use the point formula to find slope. That's fine too. Although typically for equations, excuse me, the easiest thing to do is just to solve for y. All right, so this is going to be my first one. This is my second one. I'm just going to label these. And I'm just labeling this to make my life a little bit easier and more organized. So for here, I need to solve for y, which means I need to bring this 3x to the other side. It's being added in, so I'm going to subtract it on both sides. I like to write things in order. I like my x first, so I'm just going to write that first, and then I'm going to put that positive 5 second. Now, y is by itself at this point, so I can get my slope, and the slope here is negative 3. For the second one, I have 2x plus 3y equals 6. I want to get y by itself. So first I'm going to move this 2x to the other side. Again, I really like to have things in order. I like my x first. It just makes it easier for me. I divide by 3. So y equals negative 2/3 x plus 6 over 3. Or y equals negative 2/3 x plus 2. So in this case, I'm getting a slope now of m equals negative 2/3. And if I look at my two slopes, it's pretty clear right away that there is nothing in common with these. There's no sign change. They don't flip, right? If this did flip, it'd be 1/3, not 2/3. So this is a neither. But I like this example because it does remind us that, you may not always be giving your equations in the y equals form. So if you're not, you may have to do a little bit of work there to actually, rearrange them and so on. So it's definitely something to keep in mind.